Okay, our next and our final presentation before we have a break is team number 10, Girodicer. And when the weather gods heard about this project, we should all be thankful because as a result we had a very mild winter.
All right, thank you, Professor Fasano. So yes, we're Team 10, the ECEDay drone, also known as Girodicer. My name is Luke Sorensen. Everybody else want to say their name?
I'm Carlos.
I'm Larry.
I'm Tom. I'm Yai.
All right. So the problem that we're addressing is that ice dams are a huge problem in cold climates. I'm sure many of you are familiar with the detrimental effects that they can have on your home, causing structural damage, leakage, and you just have to either shell out a lot of money and pay someone to remove the ice dams, or maybe climb up on a ladder yourself and risk your own health and safety. And so we wanted to solve this problem. So like I said, some of the existing solutions involve paying hourly workers, and that's dangerous for them too. They shouldn't be up on a roof that's all icy like that. And other options are to install heating wire on the edge of your roof, but that's also kind of prohibitively expensive and something that's more kind of proactive than reactive. So we wanted to create a reactive solution to having ice dams and trying to solve the problem. So this is our drone. It's called Girodicer, and it's a drone that can autonomously inspect a residential home for ice dams and thermal hotspots. It can place a calcium chloride payload on the ice dams and interface with an Android app to receive instructions and transfer data. Our customer was Professor Al-Sheikh.
So what's been accomplished is basically all of the things surrounding the drone in flight. So the autopilot system and simulation, the Android application is functional, the ice dam detection algorithm, the server-side data persistence, and the salt dropping mechanism. Basically everything the drone actually needs to perform an inspection properly, handle the data, that pipeline is all working. The only issue right now is we had issues with the real-world test flight due to flight controller software issues. So that's what's left to do that would complete the project.
So this is kind of our high-level technical overview. So since our drone is having to autonomously fly around, we've designed and tested an Autopilot software that'll be communicating over Bluetooth to an Android application. And we'll be taking images with our RGB and thermal camera, and we'll be doing image processing to kind of inform our Autopilot software to see where it needs to go next. And we'll be sending those images over to the Android application. We'll be uploading them online to our web services, where the person who is operating this drone can show to our clients what their house is in that kind of situation where they need salt to be deposited. So with our choice of drone, we've chose the DJI S900, and this is chosen because we need to carry approximately around 8 pounds of salt. The S900 is actually capable of doing that since they're made to carry heavy cameras. And then for the Autopilot software, so it's an event-driven program. It's written in Python, and it relies on an API called DroneKit to talk to our Autopilot software. Additionally, it's called Autopilot. It's an open source software to control a drone. And it's multi-threaded, so we can respond to events in a timely, accordingly manner as they come along. And finally, we have a Bluetooth communications protocol that's segmented into 5 parts, and it also has an acknowledgement system to ensure that we don't have any dropped packets or any kind of errors.
So the inspection system is a really vital and critical part of our autopilot system. So it's really vital for us to get all the phases down correctly and to handle any errors that occurs if like connections dropped or if we need to do another phase. Bluetooth services, communication between the autopilot system and the Android applications, really important. And that's for handling all the commands from the Android app to the drone, telling it where to go, transferring points for it to fly to, and receiving images. And on the autopilot side, it's to take in the points, process the points to calculate a path, send images over, and take in when to service an ice dam or where to fly next. And all the hardware on the drone has to be mounted correctly. Everything's connected nice and neatly, or else something like maybe a GPS will accidentally flip your drone over. And it's also important to know how to repair the drone in case of accidents or damages.
Okay, so let's talk about the image processing a little bit. The image processing is actually happening on the Intel Atom board, which is on board the drone. And it happens in real time. So as the drone is flying around the perimeter of the home, it's taking pictures at a set interval. I think currently it's set to once a second. And so we can process these images to help inform the autopilot system. So let's start with the image on the right. This girl seems very amused by the icicles and the hanging down because they're pretty beautiful, but little does she know that this home is probably undergoing quite a bit of structural damage and potentially leaking. So these icicles are actually kind of dangerous to her. So the icicle detection is using a local binary pattern cascading classifier. So this was trained over the course of about 11 hours on 3,600 positive sample images and 600 negative sample images, most of which were generated by transforming a set of about 50 samples of icicles. The classifier, you can see, works pretty well at identifying icicles in an image. The reason we're looking for icicles is that every picture of ice dams that we saw on the internet had icicles hanging down from it. So sort of the most common sense way to be able to find these ice dams was for the drone to find the icicles hanging from the roof. On the left here, you'll see a hotspot detection so the drone on its second part of the inspection run will fly over the home and in sort of a back and forth fashion. And it'll be taking pictures with a thermal camera looking for places where heat is leaking from the roof. And so we do that so that the user or the client can have an understanding of where heat is leaking, because that's where ice dams tend to form below. Because when snow melts above these hot spots, the water runs down the home and then an ice dam forms below. So a client would be able to put insulation underneath that area that's leaking heat out of the house. Another piece that's critically important to our authentication and data persistence system is our API and client web portal. So the API is a JSON based API where the Android app is communicating with JSON format and getting information back. So the everything that's you're seeing on the Android app is also persisted on our backend, so we have an account system. You can see here, I've got a very secure password, 123456. And when I supply the correct email and password over a secure connection, I get back my user information in JSON format and also a session ID. And that session ID is then used for further authentication and identification so that I'm not constantly sending my password over the network. On your left, you see an image of what the web portal looks like for the client. And so this means that someone who has an inspection done of their home can go to this website and easily view all of the images, whether they be images of the roof edge, thermal images, or images taken above the home.
So a critical component was the Android application. The Android application basically is like the middleman. It has to communicate with the Django backend, the Amazon S3 data storage, and the autopilot system that's actually on the drone on the Intel Atom board. So the communication with the backend is being done through HTTP off the UI thread, of course, so that the user doesn't see any of this happening or feel any of this happening. The data is being passed through JSON. It just makes things very straightforward for just passing data along the whole pipeline. And then a big portion of, an important component about the backend communication is using sessioning and provisioning. So the sessioning helps authenticate the request, and that's generated on the user login on the app. And then the provisioning helps so that we don't have to constantly send every single piece of data on every request. And that helps to lower bandwidth and prevent massive data usage on devices, especially in this day and age. And then communicating with the Amazon S3 server. If you look at the last picture here on the right, Those images are being served through the Picasso library. Basically, it handles images very nicely. They're being uploaded using the Amazon S3 SDK. On the first image here, there's the client manager. Those images are Google Map images. They're created by sending the address from the client. So we envision the Girodicer product being used as a service because the drone is actually prohibitively expensive. So we envision a company purchasing Girodicer and then serving clients. So the first screen here is the client manager. Here you can either select an existing client or add new clients through the floating action button on the bottom right. And then the second image here is confirming ICE stamps. So obviously detection isn't perfect. So we figured because the user interface is an app, we might as well allow them to confirm the ICE stamp just to make sure so that the drone isn't wasting time. Battery life is precious, time is precious, and it's cold in the winter. So we want to get this done over with as soon as possible. So here you can see that the user would confirm it. Here, for example, we have an image that is not inclusive of an ICE stamp, but it got detected as one, so you can just simply hit no, and then it just won't process that when it goes to service the ICE stamps. On the third image here, you can see the user can see the drone's location through a map fragment. The blue marker there is a location that was marked as an ICE stamp. When you click on the actual marker, that's when that confirm ICE stamp dialog pops up. And that's basically the Android application. And again, an important part about it was just communicating with the Autopilot system. So that green notification bar in the third image, that's just allowing the user to know what's going on. So it lets them know connectivity to the drone, did it disconnect, did it trying to reconnect, and then it also lets them know the phase of the drone so that they're aware of what's happening, because a lot of time is spent just kind of like maybe waiting. So it's a good way to notify them of what's happening.
So once we find out where the ICE stamp is, we're ready to distribute the sword. Our deadly weapon for the ICE stamp is made by a 4-inch PVC pipe, which is a custom hose on that for the attachment and the door at the bottom. The door is controlled by an automatic lock system, which is when the drone is above the ICE stamp, our machine control sends a signal with 5 volts voltage to a motor, and the motor spin put the lock out. The lock is just a kind of door bolt, so just like the image there. When the motor spins, the bolt was put out and the door is open. Then our bomb is just right placed on the ICE stamps.
And just to clarify, the payload would be calcium chloride salt in like a pantyhose, so something that's kind of like a cylinder, and the payload would be dropped perpendicularly to the ICE dam, so that it melts a channel through the ICE dam, so that any further melted snow would just run through that channel rather than building up behind. So here's our video. Okay, so it's gonna come at you pretty quick here, but I'll try to, because we only got 45 seconds, but I'll try to explain what's happening here. So first, the Android app user is plotting the points for the corners of the house, and now you'll see the drone is going off to fly a calculated path. Here we're holding up images of icicles in front of our non-flying drone. There we see the LiDAR sensor and RGB camera and the board on top. Here we're flying over the house, taking thermal images. We're processing the images. Here the Android app user is able to confirm an ICE stamp location. The drone flies to that point where the ICE stamp is located, pulls the motor, that drops the payload. Here we go, we're transferring the images now over to the phone. The phone is transferring the images to the back end, and now the client is able to get an email which has a link that they can access all the images that the drone took during the inspection, including the processed images as well. So. Did we lose our slides?
Yeah.
No. Wait, hold on. It's what's in here?
This one.
We'll just go back. 1 second. Okay.
So for concluding remarks, I think we have this Autopilot system, and our software has great potential to be implemented by businesses. So say they pay for the drone, the software, pay the upfront costs, and then they could lend it out as a service to maybe like suburban homes. Like say like, hey, for $50 we can remove these ice dams for you. So in terms of getting the drone to fly, I think we're a little bit hesitant to take it out to test again because we need better sensors that cost a couple $1,000. Better autopilot system costs another $1,000. So and also there's some legality issues because like in the past year like the FAA really like cracked down on drone flying, so there's like tons of no-fly zones, more regulations of what you can't do. So these need to be addressed first, and I think that's about it.
Yeah, you're really not allowed to fly a drone around a residential home.
Yeah.
But like Larry was saying, the drone could be another sort of service that there's ice dam removal companies, especially here in New England, and they'll charge $350 an hour to do it with manpower, and that might be too expensive for some people. So if there was some cheaper option that may not be just quite as effective but still works, that would be beneficial to tons of people who have ice dam problems. Thank you.
So I guess there's confirmation that dumped payload, but did you think about, other image processing to confirm that it actually landed on the roof, and it's not just like on the side?
Definitely a next step.
And to explore other applications besides ice dams.
So we are flying over the roof. So additionally, you could do it over summer. Say like you're in another region that has hail damage, so you could do just flying over the roof with you basically rearrange the cameras, and you can now have an RGB camera that's taking video footage of your roof and assessing roof damage.
Yeah, currently we have an RGB camera that faces parallel to the ground and a thermal camera that faces down. We wanted to either implement some sort of motor that swivels to allow the RGB camera to also face down, so that you would be able to perform an aerial inspection and get both RGB and thermal imagery. So it could be used just for routine inspections of homes in addition to preventing ice dams, so fixing ice dams.
Okay, thank you.